Okay, we are back with polynomial expressions. Module 2 notes, part 2. We're going to be looking at division. We just did multiplication. We also did reducing rational expressions before that, and we talked about simplifying and evaluating rational expressions. So for division, we want to think about the keep, change from multiplication to division, and then we want to flip the divisor. So we want to keep, change, flip. So I want you to think about that in your mind. So whenever you have division, you're looking at this, you're probably going, oh my God, what is that? But this is really division of two rational expressions. We've got x squared minus 9 divided by x squared plus 7x plus 10, all divided by x plus 3 divided by x plus 2. So here is a rational expression divided by a rational expression. So what we can do is just rewrite. So the first thing I want to say is go ahead and if you have a complex rational expression, which is what this is, just rewrite it. So we're going to go ahead and do that. This becomes x squared minus 9 divided by x squared plus 7x plus 10 divided by x plus 3 divided by x plus 2. Okay, so when we're looking at this, when I say keep, change, flip, what we're going to do is we're going to keep the first rational expression the same. We're going to change the division to multiplication, and we're going to flip the divisor so that the denominator becomes a numerator and the numerator becomes the denominator. And we're going to just change it into multiplication and make the whole process simpler to accomplish. But in doing so, though, we have to think about the domain. So for the domain, we have to remember that we have to take the original. We have to worry about x squared plus 7x plus 10, and x plus 2 cannot equal 0. So we have to deal with these two not equaling 0. And then we're also, when we flip it, we have to worry about the new denominator for the divisor. So let's go ahead first before we do anything, and let's go ahead and factor. We want to first thing we want to do is we want to look and see if there's a greatest common factor. Then we want to factor anything that is. Then we want to do look at the domain of the original. Then we want to keep, change, flip, and reevaluate domain. And then simplify. So I'm writing these steps down this way because if there's a greatest common factor, we have to deal with that. If we can factor, we deal with that. Check the domain for the two pieces of division that we have now. We keep, change, flip, and then we reevaluate the domain for the divisor in its new state, and then we do the simplification. Okay, so let's go ahead and do that. See if there's any greatest common factor for here or here. I'm looking at this, I don't have an x here, so I can't factor anything out there. I don't have a numeric part, so I can't factor out any numbers there. Here, I do not have an x in every term, so I can't factor out a variable, and I can't factor out a number that is in common to all of these. So nothing here has a greatest common factor. There's no greatest common factor from either of these. These are just simple binomial factors when we're looking at that. So let's go ahead and factor the first two. And this is the difference of two perfect squares. And this is a simple trinomial. So the difference of two perfect squares, we're looking for perfect square and a perfect square, and we put a plus and a minus square root, I'm sorry. So the square root of x squared is x. The square root of 9, not the minus, but just the 9 is 3, and we use plus and minus in the middle. So there is the first one, factor. The second is a plus and a plus, so the middle of each of the binomial factors has to be a plus and a plus because we didn't factor anything out. We're looking for 2 factors of 10 that will equal 7. Well, our variable is x again. 10 is 1 times 10 and 2 times 5. Well, the only way to get a 7 is our 2 times 5. We're dividing this by x plus 3 times x plus 2. I'm keeping it in the original form. So our domain, we look at the original. Our domain, we've got x plus 2 cannot equal 0. We've got x plus 5 cannot equal 0. And we've got x plus 2 cannot equal 0. So we don't need to rewrite it again. We'll just remember that we have it twice. So now what we want to do, we've done greatest common factor, we've done factor, we did the initial domain, now we want to keep, change, flip. So we're going to do our keep, change, and our flip. So we're going to leave this one exactly as it's written. So x plus 3 times x minus 3, x plus 2 times x. We're going to multiply that by x plus 2 divided by x plus 3. So now we have to reevaluate our domain and with the new denominator. We've already taken those two, but now we have to look at this one. So x plus 3 cannot equal 0. So we've got everything. We did this, 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 and this. So just remember when you get down to where you're working at full speed, you just have to go this, this, and then this, okay? So now we've got all parts. We're going to simplify. Remember, simplifying when you have multiplication, you're just multiplying across the top, multiplying across the bottom. You're not multiplying out. You're looking to see what you can divide out. So we're going to divide out. Which most people say cancel. I don't like to say cancel because that's really not the real term. So we can divide it out an x plus 3 from the numerator to the denominator and you get 1. You can divide out an x plus 2 from the numerator and you get a 1. So our remaining expression is going to be x minus 3 divided by x plus 5. Put them in parentheses, please, for Lumen. Lumen can't figure it out. It's not really very smart. Provided that x does not equal, so x cannot equal negative 2, x cannot equal negative 5, and x cannot equal negative 3. So x cannot equal negative 2, negative 3, and negative 5. Okay, so here is our answer. I'm going a little bit quicker now that we've done the multiplication simplification, but I just wanted to make sure that you got each piece in there. So if you have any questions, make sure you go back to looking at the multiplication, go back and look at the factoring in part 1. If you have any questions, just also look at the videos or check with me, your professor. So the next question, dividing out rational expressions. We have 8x cubed plus 1 divided by 2x divided by 2x squared minus 5x minus 3, all divided by x cubed plus 2x squared minus 5x. All right, so greatest common factor, if there is one. Factor every term, every polynomial in each of the fractions. Domain, check the domain. Then do keep, change, flip. Look at the domain again for the divisor, the one that's being divided, and then simplify by canceling out or dividing out the common factors. All right, I'm not going to write that again, but the first thing we want to do is look and say, do I have a greatest common factor? So here, I cannot divide out anything. Here, it's just a simple term. It's just 2x, so there's nothing that we can do there. Here, there's no variable in all three of them, so no variable can be divided out. You can't divide out a variable from the first two if you can't divide out a variable from the third one. That is a no-no. I can't divide out a number from each of them, so no greatest common factor. But the denominator down here, we've got x cubed plus 2x minus 15x. I have an x in each one of those, so I can divide out a greatest common factor in here. So I'm just going to, underneath here, I'm going to write x times x squared plus 2x minus 15. That's going to be my new, I just factored out that. Now I look at this one, and this is a trinomial where a is greater than 1. So I'm going to have to use the AC method. And this one right here is 8x cubed plus 1. Perfect cube, perfect cube, perfect cube. This right here is the sum of cubes. So you need the sum of cubes formula. So we have a little bit more of work to do here. So I'm going to come over here and I am going to write the sum of cubes formula. The sum of perfect cubes are when you have a cubed plus b cubed, it's equal to a plus b in parentheses, you can't forget the parentheses, times a squared minus, if it's a plus here, it's got to be a minus, it's opposite, a times b, and then plus, these are going to be opposites, b squared. So what you have to do is you have to find out the cube root of a, the cube root of b, then you square a and square b, and then just multiply a times b together, and just watch your signs. So here we have 8x cubed plus 1. So I'm going to find, this is my a cubed, and this is my b cubed. So the cube root of 8x cubed, that's my a, is equal to 2. Cube root of 8 is 2. Cube root of x cubed is x. B is equal to the cube root of 1, which is equal to 1. 1 is a perfect square, a cube, a fourth, a fifth, everything. So a squared is equal to 2x squared, which is equal to 2 squared times x squared, which is 4x squared. You have to multiply the 4 out. B squared is equal to 1 squared, which is just 1. And then a times b is equal to 2x times 1, which we know would be just 2x. So there's your pieces parts. You need the 2x, you need the 1, you need the 4x squared, you need the 1, and you need the 2x. So they kind of look a little bit like each other in places. So this is going to be equal to 2x plus 1 in parentheses times 4x squared minus 2x plus 1. This is a formula, guys. It's not anything mystical, magical, or a miracle. It's just a formula. You have to find these 5 pieces. It's the same thing when you have the difference of perfect cubes, except for the formula would be minus, plus, plus. So just find the 5 pieces and fit them into the formula. Don't try to do anything more difficult, okay? Don't do anything weird or wild or magical, okay? You can look to see if this can be factored, but I'm going to tell you right now, this is not factorable at this time. It's not factorable with whole numbers. So if we're looking at this, now we have 2x plus 1 times 4x squared minus 2x plus 1 divided by 2x. And then we're going to divide that by, now we have to do the AC method. So here's my work over here. I don't have my domain at this point. I just have my work. So we have the AC method. So 2x squared minus 5x minus 3. So A times C is 2 times negative 3, which is negative 6. I need 2 factors of negative 6 that equal negative 5. This is a negative negative, so it's got to be a negative and a positive number. And so in order to get this, we're going to have a negative 6 and a positive 1 in order to get negative 5. Be very careful. Now I'm going to write this out as a 4-term polynomial with negative 6x and a positive 1x. So 2x squared minus 6x plus 1x minus 3. There is my negative 5x right here. So now I'm going to do a factoring by grouping method where I factor out the greatest common factor from these 2 terms and I factor it out from these 2 terms. So from 2x squared minus 6x, I can factor out an x. From 1x minus 3, it looks like I can't factor anything out, but if you can't factor anything noticeable, you have to factor out a 1. So what's remaining when I factor out an x from, oh, I can factor out a 2x, excuse me. I can factor out 2x. So when I factor out a 2x, I end up with an x minus 3 as a binomial, and if I factor out a 1, I'm left with an x minus 3. Okay, so my binomial factor is x minus 3 times my second binomial, which is 2x plus 1. So I have divided by x minus 3 times 2x plus 1. And then it's going to be divided by x times, and then x squared plus 2x minus 15. It's a positive negative. To get a negative number here, you have to have a positive and a negative. So 2 factors of 15 that will give me a positive 2. Well, the 15 has got to be a 3 and a 5, so you have to have a positive 5 and a negative 3. 5 times 3 is negative 15. Positive 5 plus negative 3 is a positive 2. And my variable is x times x. So this is how our thing right here is rewritten. Now let's look at the domain. Domain. We have to start at the beginning. So we have only looking at the variable. We don't need the number. X cannot equal 0. We already have x cannot equal 0. So now we have x plus 5 cannot equal 0, and x minus 3 cannot equal 0. Well, you know what, guys? We already know that we have to flip it. So let's look at the numerator. We have x minus 3 cannot equal 0. Well, we already have that. And then we're going to have 2x plus 1 cannot equal 0. So there's our pieces parts for the domain. We have x, x, we don't need to write it twice, you only need to write it once. X plus 5, x minus 3, you don't need to write it twice, and 2x plus 1. So these are our pieces parts for the domain for the division. Now we're going to keep change flip. And we're going to go ahead and smush it together because it'll be multiplication, and we're going to divide out factors. So it becomes 2x plus 1 times 4x squared minus 2x plus 1 divided by 2x. And we're flipping this here. So this becomes times x plus 5 times x minus 3. And then this becomes times x minus 3 times 2x plus 1. And now we look and say, can we divide anything out? So I'm looking through. And remember, 2x really means 2 times x. So we're looking at multiplication there. So I look and I say, I've got a 2x plus 1. I can divide out 2x plus 1 from the numerator to the denominator. I can't do anything here, but I have an x and I have 1x. So I can divide out the x there. I'm left with a 2. I have an x minus 3 and an x minus 3. I can divide those out. And I have an x plus 5, but I don't have one on the bottom. So my simplification is going to be 4x squared minus 2x plus 1 times x plus 5, as long as x does not equal 0, subtract 5, negative 5, add 3, so positive 3, and then I'm going to subtract 1. So I'm going to write that down. I'm going to subtract 1 and divide by 2. So there's my domain. Here's my answer and my domain all in one place. It becomes, this rational expression just becomes a plain trinomial times a binomial, and you do not have to multiply it out. Just leave it alone. So there's your answer. Okay? So one more that we're going to do, and then I will stop there before I move on to the next part. So now we have a multiplication and a division of rational expressions. So when you have multiplication and division, whenever you have division, the division part is the one that you flip. The rest of them you leave alone. So if the division's in the middle, that's the one you flip, but you always keep the multiplication by itself alone. So we have multiplication times 1 times another divided. Keep, change, flip. Keep, change, flip. We need to know the domain of this, the denominator, and numerator. We only find the domain of both the numerator and denominator of the one that's doing the dividing. So, domain of both. I'm not going to write them out, but I'm just going to say that's what we have to do. So pieces and parts. I'm going to write domain over here, and we're going to work on it as we go. Okay, we'll take the pieces and parts as we go, but we're going to also do the factoring as we go. So we have multiplication, and it's going to end up multiplication because we're going to keep, change, and we're going to flip. Okay, we're going to flip these two. I want to make it quicker and a little bit faster. So x squared minus x minus 20 is a subtraction. So you are going to end up with two binomials. To get a negative here, you have to have a negative and a positive. Negative times positive gives you a negative. We need two factors of 20. We'll add to a negative 1. So we have a 5 and a 4. In order to get a negative 1, you have to have a negative 5 plus a 4 to get a negative 1. Negative 5 times 4 gives you a negative 20. So we're going to have an x and an x. The denominator is 25x squared minus 1. This is a binomial with subtraction, and it's got a squared on it. So we look to see if it's a difference of two perfect squares. So this is the difference of squares. So we take the square root, and square root. It's in a minus. So 25x squared, the square root would be 5x. And the square root would be 5x. So 5x times 5x is 25x squared. And 1 times negative 1 gives me negative 1. So a little bit more complicated here, a little bit more complicated here, because I do not have a greatest common factor that I can take out. But I have a difference of two perfect squares here, and I have something a little bit more complicated here. So but we're going to flip here, and I'm going to do my difference of two perfect squares. And this is going to be x plus 4 times x minus 4. 4 times negative 4 is negative 16. X times x is x squared. So I have 3 out of the 6 that I need to do. And for the domain, we have 5x plus 1 cannot equal 0. 5x minus 1 cannot equal 0. We've got, I'll keep them, but we're going to have those two as well. So this is just the first one. I'm going to do them in order. So let's look at, here's our work. So I'm going to look at 5x squared minus 21, x plus 4. I'm going to do the AC method. So 5 times 4 is equal to 20. We need two factors of 20 that equal negative 21. It's a negative positive. To get a negative 21, you have to have I'm sorry, I just had a brain freeze. Excuse me, that happens. Two factors of 20 that will add to a negative 21. So this is a positive. So you have to have either a positive times a positive or a negative times a negative. To get a negative number, it's and a negative. And so the only way to get a 21 would be a 20 times 1. So negative 20 and a negative 1 would be a negative 21. So now we're going to write this out. 5x squared minus 20x minus 1x plus 4. Here is my negative 21x right here. Now we're going to factor by grouping. I didn't mean to freeze earlier. Sorry about that. And we're going to look for the greatest common factor. I have a 5, and I can take out an x from each of those. So I have a 5x, and I'm left with x minus 4. So here I have a negative 1x plus 4. Whenever you have a negative starting, you have to factor out a negative. Well, they don't have any factors in common, so I have to factor out a negative 1. So when I factor out a negative 1, just the signs change. So it's going to become minus 4. That means I have a common binomial factor of x minus 4. And then I have 5x minus 1 as my second binomial factor. So this is going to go in the numerator. So I have x minus 4 times 5x minus 1. And if you notice, we're already seeing some good things. We can divide out this, we can divide out here, we can divide out here. So we're looking for numbers that will divide out. So good stuff going on here. So there's our first one. Now let's look at 3x squared minus 13x minus 10. We have a negative number here, so we're going to have a positive and a negative. To get a negative 10, you have to have a positive and a negative. So this is also the AC method. So 3 times negative 10 equals negative 30. 2 factors of negative 30 that will give us 10. Well, negative 30 is 1 and 30, 3 and 10, 6 and 5, and so let's do 1 and 30. Oh, 2 and 15, 3 and 10, 5 and 6. Oh, I'm sorry, this is negative 13 that we're trying to go for. So we're looking at this one right here. Oh, are we? I'm going to stop here. I made a little bit of an error. We were trying to go for negative 13. I didn't want to confuse you. So I want to back up. We're looking for a negative 13. So I should have written equals negative 13. So this is a way to help you not make a mistake. I should have written the negative 13. So remember, there's a 2 and a 15, and there's a 3 and a 10. Notice I can make a 13 with a 3 and a 10, but I can't get a negative 13 from a 3 and a 10. And to get a negative 30 out of that. So looking here, the only way to get a negative 30 is a positive 2 and a negative 15. That's going to give me a negative 30. So these are my answers. It's okay to make a mistake. Just learn from your mistakes. So we've got 3x squared. And I'm going to flip these around. I'm going to do the negative 15 first. And so it's negative 15x and a positive 2x. You're allowed to do that because if I had said negative 15 first and a positive 2, I would have done that first anyway. And then minus 10. So I'm going to do my factoring by grouping. Find a common factor for these two. I have 3x. And then I have x minus 5 is my binomial factor. I'm going to take a positive 2 out. And I have x minus 5 as my common binomial factor. So looking here, x minus 5 is the common binomial factor. And I have remaining 3x plus 2. So this goes in my denominator. All right, so now I have 2 more denominators that I'm going to deal with. So I have x minus 5 cannot equal 0 for my domain, and 3x plus 2 cannot equal 0. And I'm going to go ahead and put in the x plus 4 cannot equal 0, and the x minus 5 minus 4 cannot equal 0. So I'm just missing this one because that will go to the 9x squared plus 12x plus 4. So I've got one more work to do. So 9x squared plus 12x plus 4. And once again, we're doing the AC method. 9 times 4 equals 36. We've got a plus plus, so we're going to have a plus plus. And we're looking 2 factors of 36 that equal to 12. And if I look at my factors of 36, you're going to have 6 and 6. They're the only ones that are going to work. So I'm going to go ahead and rewrite. I've got 9x squared plus 6x. Plus 6x plus 4, and I'm going to go ahead and factor by grouping. And I'm going to take out the greatest common factor from 9x squared and 6x, which would be 3x, and I have remaining 3x plus 2. And I take out the greatest common factor from 6x plus 4, and I have 2 as a positive 2, and I have a remaining binomial of 3x plus 2. So I take out the common binomial factor, 3x plus 2, and I have a factor of 3x plus 2. So really, I'm going to write that up here, and since it's the same binomial factor, I have to take it twice, but for the domain, I only need to write it once. Oh, and I already have it right there, so I don't really need to write it again. Since I have it once, we don't need to write it again. So, my domain, x cannot equal -1 divided by 5, so -1/5. X cannot equal, and I'm kind of, my line is screwing up here, add 1 and divide by 5, add 1, divide by 5. So x cannot equal 1/5. Add 5, x cannot equal 5. Subtract 2, divide by 3. So x cannot equal 2/3. And x cannot equal -4. And x cannot equal 4. Okay, so there's my domain, all of my domains. So let's go ahead. We're going to extend the multiplication because we already changed and we flipped. I'm going to go ahead and, because this right here, once again, is 9x squared plus 12x plus 4, and this right here is x squared minus 16. So go ahead. We're going to divide out. So we've got an x plus 4. Well, we've got an x plus 4. And I'm going to divide out. We've got an x minus 5, and we've got an x minus 5. This is just a strategic game. We're knocking out our men. We've got an x minus 4 and another x, and an x minus 4. We got a 5x minus 1 and a 5x minus 1. Careful, because there's a plus 1 right there. And we've got a 3x plus 2 and a 3x plus 2. So we look and say, what's left? And our answer is going to be 3x plus 2 divided by 5x plus 1. Put them in parentheses because Lumen can't figure it out. As long as x does not equal -1/5, 1/5, 5, -2/3, -4, and 4. Okay, so there you go. There is the simplified answer and the domain. All right, guys, that's the end of division.